The city is probably the oldest, most enduring invention of our civilization. The words are interchangeable: civilization, civil, civic, city. Cities evolve over time. They respond to crises, and historically, they emerge from crises stronger than ever before. So what are the future trends for cities, and what are the lessons of history?
So my name is Dirk Hebel. I'm professor for sustainable construction at the Karlsruhe Institute of Technology in Germany. And I will talk today more or less about the question how we're going to build our future cities in terms of resources. It is an important issue as we know that, for example, our current cities or our building industry at large is using 50% of all primary resources globally, as well as consuming 50% of all primary energy. So if we're going to talk about a future city or how we conceive the building industry in the future, I think both issues are super important. Number one is where the energy comes from that we are needing to do so. And the second question will be where the resources come from in order to do so. The magnitude of this question is rather large. In order to understand this question, we could think about one of the most used resources in construction today, actually the most used building material today, which is concrete. It is believed today that more than 50% of all man-made objects in our world are actually connected to cement, the main ingredient in concrete, in one or the other way. And this is a global phenomenon. So we're not talking about only Europe, we're not talking about the US or the Australia or Asia alone or Africa alone. We're talking about a global phenomenon where concrete became the most dominant building material worldwide. This tendency has severe consequences for our environment. And I'm sure all of you heard already that we talk today about sand wars. The reason why is that in these concrete mixes, approximately 1/3 comes from the resource of natural sand, 1/3 comes from gravel, and another third is actually these so-called binders, meaning cement and other additives that over the years we added to this mixture. I said before that we talk about sand wars. That comes from the fact that the resources we need to kind of fulfill our need are natural ones, meaning that most of the sand today and the one that we are using in the building industry is actually coming from so-called water-based sources, meaning either from rivers or from the ocean. And the magnitude is so big that we have a fleet now established worldwide with ships running over our oceans in shallow waters and sucking the sand into these ships and then bringing them to places where we are washing and sorting these sands and then basically feeding our concrete industry. The same is true for gravel. As we a couple of years ago only talked about this shortage of sand in areas like the northern shore of Africa, where, for example, countries like Morocco claim that they lost 50% of all of their beaches. On one hand, because so-called sand pirates more or less drive with their trucks to the beaches and start shuffling the sand onto their trucks and bringing them out of the country, mostly to those areas and places in the world where that hunger is for sand and concrete is the highest, or that these ships I talked about, these fleets on our ocean, are sucking the sand in shallow waters. And therefore you can imagine that when you create holes on the bottom of the ocean, the sand sitting on beaches, on islands, and on shorelines is more or less sinking towards these holes and therefore disappearing on shorelines. Indonesia, for example, is claiming that Singapore, because of this sand hunger in the state of Singapore, is responsible for the loss of 80 islands belonging to Indonesia. And you can see that there are many conflicts happening around the question of where we get the resources for this concrete hunger that we are observing worldwide. But as I mentioned, this is only one example of where our resources, and I would like to make a distinction here between the term of resources and reserve. What we understand by resource is the total amount of a natural material that globally is available. But the reserve is more or less that amount of the resource that today, with technical means and with economical and ecological means, we are able to source. A lot of countries, also the country I'm living in Germany, did already calculations how long this reserve will actually take us if we continue to use those materials as we do today. And it is actually shocking to see that, for example, when we look into metals, especially into zinc or into zinc or into copper, that these reserves are actually very close to run dry. So we're talking about a couple of decades, in some cases only 25, 35, 40, 50 years, as long as these reserves will be available for our society. That means on one hand, we are running out of these reserves, and number two is that the economical factor will play an important role. And we see it already in some of these materials, building materials around the globe, that prices for such materials are increasing exponentially. That means that we have to have a rethinking, that we are running into a dead-end street if we continue to act the way as we did over the last decades, and that we need to think strongly and in a kind of a paradigm shift of how we think that these resources or where these resources come from in the future to continue to build our future cities. It is necessary to do so. We know that the global population is increasing. The numbers of the UN and other institutions are showing curves that will not actually kind of flatten, but in the contrary, that in a lot of areas around the globe, mostly in Asia, Africa, South America, Middle America, that these numbers are actually rising. And in order to provide housing, in order to provide infrastructure, and to provide a living in dignity, it must be our primary question and our primary research where the resources come from in order to supply these people with dignity. When we think about what alternatives we have, I would like to discuss today two with you. One is very obvious. It is the fact that our built environment is actually a gigantic reserve of building materials. The problem is that today we are not tapping into this reserve. The way how we build, the way how we live, the way how we consume could be described as a linear system, meaning that we are taking something out of the earth crust, a material, that we are producing something out of it, a product, that we then use that product to provide spaces and build cities. But that after that use, we usually think that all of these materials and products are useless. So we either burn them, mostly in Europe, or we putting them into landfill. So that this cannot be a sustainable method. So on one hand, understanding that we have no more reserves to come into this linear systems, or that the reserves are getting actually super short in a quite some time. And on the other hand, burning or landfilling these valuable materials is not a way we should prolong. So in recent years, a term came along that was used as urban mining. So the idea that in the fact that the existing built environment could actually be our new reserve. In the first moment, that sounds, of course, fantastic. So basically understanding our built environment not anymore as a single linear system, but saying that we need to start to have a circular system so that these building materials and products, after their use, are not burned or landfilled, but they're actually the source for new buildings and new urban settlements to come. What is said very easily is actually quite a heavy task to do, because that means in the end that we have to rethink, and I would even say that we need to reinvent the way how we build. Because in order to make that system a circular one, the question, of course, is on one hand, which materials allow that? And number two is which connection systems allow to do so. We're talking in this realm, in the ideology of a circular industry or a circular building industry, in these two fields. So number one, we need materials which are either recyclable. That means that we are sure that these materials, when we take them out of an existing system, we could reconfigure them in order for them to become new materials for the future. This requires quite a lot, because these materials are rare. These are usually building materials and products which are not composites. So that means that we are not mixing different materials and components together, that we don't glue them together, but that we keep them in a pure state. As one example, that we keep them as glass and don't mix this glass, or don't put foils on our windows, for example, or other metal fuses that in the end protect, on one hand, of course, during the use as a window, as a glass window, radiation to enter our buildings, but in the end kind of prohibit a circular system, and therefore do not allow these materials to become of a circular metabolism. So that means we have to think hardly about the materials and how we produce these materials for a circular construction market. Meaning that when I don't use this material anymore, it must be super easy and with the lowest amount of energy that I could turn them back into a virgin or a secondary turn as a virgin material. The other part I mentioned already is the way how we connect these materials or products. Meaning that we have to reinvent our construction industry in such a way that we are not allowed anymore to glue things together, to use silicons, to use paints, to use any coatings, which again will prevent these materials and products to be circular. So therefore, we have to think about how to connect, for example, insulation materials to our structural systems, how to connect interior applications towards our structural system, and that it is done in such a way that it must be super easy to take these materials and buildings components out again without destroying them or without them being connected to other materials and components, and therefore being not able to be recycled. There are many people thinking about this already, many architects and engineers starting to think about these connection systems. And what is very promising lately, that out of this ideology, out of this thinking, and how we can construct in the future so that we can take, I would say, snap and fit connections instead of glued and kind of foam connections or any lacquers or anything that cannot be taken apart anymore, will create, in my view, a fantastic opportunity for our economy in order to also think of new economical systems. So in the Netherlands, for example, there is a company that invented a new carpet where the back of the carpet and the loop of the carpet is made out of the same material. So usually when you look at carpets, these are different materials, composites, right? So you have one foam and you have a plastic material and you have a PE material, and all of them are glued together and they heat it up. And in the end, it's a mess. And the only thing you really can do with it is burning or landfilling it, because you're not able to take the reserves out of this product again. But as I said, this company invented a new way how to manufacture their carpet with only one material, only one. And they also invented a way how to put the carpet down on the floor without gluing it. And therefore they realized, well, why would we in the future sell our product? What we should do is actually only lend this product to the user. The user then is able to use this material as long as they want, or as long as the product is in good shape. And the moment they think they need to exchange that carpet, they call the manufacturer. The manufacturer will come with a new carpet, take the old one out, which is very easy because it was not glued down, brings it back to the manufacturing line. And because it is made out of a single material, they can use this material again to produce new carpets out of it. So their business model is not anymore based on the idea of selling a product, but their business model is based on charging for the use of this material. And a very beneficial system, of course, is that they, in the end, are independent from the question of reserves, as I mentioned in the beginning, because they're really urban miners, so they can take out these materials and bring them back in the loop. So I think the idea, as Ursula von der Leyen in September 2020, as the president of the European Commission, mentioned that the European Communion by 2035 would like to introduce a fully based circular economy, does have, of course, obstacles. It does require to rethink and to kind of reinvent our building industry in big term, but on the other side, offers new opportunities. And I think we should look at that side. We should look at the opportunities that we could create also with architects and engineers and product designers, in order to make that a new model, a new business model that allows us, even in Central Europe, where I'm based in, which is an area which is low on resources and reserves in terms of building materials, how we can use the existing elements, the urban mining idea, the existing cities and the built environment in order to change the system. Now it is clear, in a perfect world, let's say in 50 or 100 years, if all of us, architects and engineers, are starting to design in such a way, it would be very, very easy to take all of these materials and all of these building products out and put them back into the loop. But now the question is, what should we do with everything that we built so far, which is not following these ideas? And therefore, I think that term urban mining is a very good one, because a mine, as you can imagine, is something that is dirty, that you have to put a lot of energy in. It is dangerous. So you have to go back into that urban mine that is existing right now and is not designed in circular terms, and see what we can get out of it in a very difficult process. So the urban mine, as it is existing today, and not designed to be a new reserve, is a very hard and a very harsh idea how to bring back these materials and components into our system. And therefore we need innovation. So a lot of companies are thinking, also again, an example out of the Netherlands, where they found a way how to recycle concrete. So making sure that the sand and the gravel and the cement that we put into the concrete mix, as I mentioned before, we're running out of sand. So it would make sense to have a new technology that turns our existing concrete buildings back into virgin or secondary virgin materials. And I think here is another step when we think about a future of our building industry in future cities, another business case. The first one described the way how we can have a product design, making sure that we can use it all over again. The second base or innovation hub or business case should be the way to develop new technology that makes sure, for example, that we can bring concrete back to the stage, that we can lay out the original materials in front of us and then build new ones in order to achieve a circular economy. Not all of these materials of the existing urban mine, the built environment today, will be able to be used. You can imagine that a lot of these materials are put into that mine sometimes 100 years ago, 50 years ago, 60 years ago, and that we know today, which might, for example, be toxic. So all of those materials that we would not like to circulate into a new economy, we have to take out and we have to store them somewhere in order to develop new technology that maybe in 20, 30 or 40 years, so we are able to also take these difficult or maybe even toxic materials and have ideas how also to bring them back into a circular system. So this is a big task. It is the idea, and I try to distinguish between the question of the urban mine, so something that was never designed to be in a circular mode, and a circular economy, meaning that we have to start today everything that we build new under these circumstances, or let's say under these conditions, so that we are able to take them out again without any loss, on the same quality and the same quality of materials and components. And you don't have to be a mathematician to figure out, even if we would take everything that we're taking out today of our cities and recycle that, it would not be enough to fulfill the need that we have. I described the fact that our population globally is growing. And therefore, of course, we cannot simply rely on the fact that we take the existing building stock and say, well, that is the reserve for our future. There's a gap because our demand gets higher. And the question is, how do we fill that gap? And my view on this one is that we have to look into biology. So if we are running out of minerals and metals, and we know that these resources and reserves are ending, and we also know that there's not every day coming a new asteroid and bringing new material to our planet Earth. We know but for a fact that the sun is bringing endless energy every day to our planet. And it brings 10,000 times more energy every day than we actually need. That means that the sun is the only open system that we have available on our planet. So remember, in the beginning, I said the two biggest questions are resources and energy. So the resource part I discussed a little bit and give a hint. And now let's talk about the energy part. And that energy is more or less for free, right? And it's turning our system. It is paying the bill, let's say, for how to fuel our circular economy. And it is very interesting to understand that we need a new class of building materials that is coming much more from the biological side. Because this biological side, we know for a fact that wood is a very, very old building material, but I think we have to broaden the scope of how we think about the question of biological building materials. Ourselves, we are researching, for example, on mycelium. So we try to understand the idea that in the end we could grow building materials not on agricultural fields and therefore get in conflict with the food production, but how we can take mushroom spores and grow in our cellars in spaces which are not used usually for the agricultural and food production, how we can use these biological concepts and ideas and growth mechanisms in order to grow future building materials. We also look into grasses I think looking at bamboo or looking at hemp and other grasses, we know that they are very good materials in terms of tensile capacity. So similar to steel that we use in concrete. The steel is responsible for taking the tensile forces, and the concrete is responsible for taking the compression components. We could think about new construction systems where, for example, grasses as bamboo or hemp taking the tensile forces, and mycelium is more or less the root network of mushroom, could take the compression components. And therefore, rethinking our idea of how building systems, I mentioned before that concrete is the most used building material worldwide. So could we think of a system, a same system, right? The same thinking behind it, but this time coming not from the mineral and metal source, but coming from the biological source. And I think also here, that's another business case, right? That we can advance our understanding as architects and engineers, that we can do research in how to make these materials available, how to grow these materials. And that could be extremely interesting for emerging territories, because I think there is also an advantage in these territories that they don't have to redo all the mistakes that others did already. So why running into the same dependency on sand and gravel and cement and steel as was done somewhere else already, and instead of jumping into a new paradigm by saying that, for example, a new class of building materials should be the biological one, a kind of a biological revolution. That is not new. This thinking is not new. So it is called the advantage of the latecomers. When you think, for example, of the cellular phone, it is very obvious that a lot of territories on our planet did not have a kind of established landline system for telephones. But the moment cellular phones came on market, most of these territories simply jumped this stage of having landline phones and jumped directly into cellular phone systems. And in such an advanced stage that I always say that I lived for quite a while in Ethiopia, in Africa, that going to Ethiopia today, I have to say that looking there how a cellular phone can be used in terms of making an economy move and turn is so much more advanced than here in Europe, that this gives at least me hope that also with our building industry, a lot of jumps, a lot of kind of frog loops can be established in order to be in an advantage situation compared to other systems. So therefore, the question of biology, the question of how we understand biological materials in the future, next to the established one, will broaden our palette. And I think it's important to understand, and that's what the research we are doing in Karlsruhe at the Karlsruhe Institute of Technology is basically focusing on those two areas. On one hand side, understanding the existing built fabric and understanding that as an urban mine, but also paying attention to a vision of the future that we cannot build any more urban mines, but we should build circular systems. That is number one. And the second focus of our research at KIT is based on the question of biological building materials. So making sure that we establish a new class of building materials which can be grown everywhere globally without being in any kind of congruent situation with the food industry. So therefore, in a nutshell, that is what we're trying to do, what we do at KIT. And I hope that we can inspire as many of you to think in these terms, to think differently and to think out of the box, and to trust your own research, to trust your own gut feelings, and to make a new vision for a building industry might come true. Thank you very, very much.